I'm Sean Gannon, and this is Minute Math. And we have a classic find x problem. We have a given figure here, and we have to find x. Now, let's go note some things about this figure. We have here a semicircle going on, right? Semicircle at center C, right? And we have a little right angle here, and it's at a point of, well, tangency, where this angle here connects, right? Boom, and it connects here at D. And we want to find, well, x, the distance between E, B. All right. The circle has a diameter of 2 and a length here from A to E is 1. With just this information, can you figure out the value of x? So pause this video if you think you're up to the challenge to figure out what x is, but if you're not and you just want to watch me do it, well, we're gonna go dive in, and I'm gonna show you a way to solve this problem and really my thought process and how to solve the problem. All right, first things first, I notice here if EF, the diameter is 2, our radius is equal to 1. Cut it in half, pretty easy. And our radius, we can probably draw a radius here from C to D. So let's connect CD here. We connect CD, and that length here is, well, 1. It's our radius. Now here's the tricky thing, right? Because CD or DC, right, is at the tangent point of this line to the circle, the tangent to the circle theorem states that, hey, this is a right angle here, okay? Important to note here, we had a right angle going on right there, okay? So now, well, we gotta figure out some other angles here. So I'm gonna call the angle here from BCD angle, BCD. I don't know what that is, I'm just gonna call it alpha, okay? There's a little alpha angle here, and I'm gonna use that alpha variable here to really set up some other things that maybe we can figure out in terms of alpha, okay? Well, if this angle here, right here, D or CD with the line AD makes a, perpendicular line, that means the inside is also perpendicular. So we have a 90-degree going on right there on the inside, okay? Now watch this. If we have a right angle here, EBD, DBC is also a right angle. So what about this little section here? The whole thing is, well, 90 degrees, but we know that every triangle, or the sum of the interior angles, have to add up to be 180 degrees. So if this is 90 degrees right here, we minus a 90, left over the other two corners here have to add up to be 90 degrees. So that means that angle CDB has to be alpha minus a 90 degree, other way around, 90 minus alpha. Hey, we all make mistakes. Maybe I'll cut it out, maybe I won't. 90 minus the alpha. So whatever the alpha degrees is, 90 minus that will be this one right here. So that's 90 degrees minus our alpha. Okay, we're getting close. What I want to do now is see if I can establish some similar triangles here. I have two big triangles I'm working with. Okay, we have our big one, and then our small one. So if we have our two triangles, let's go write them out. We have our triangle CDA. All right, CDA, we have an alpha angle here, we have a 90-degree angle right there, and just like we saw before, this angle right here should be 90 degrees minus our alpha, because they both share that same alpha here, and then we have a 90 degrees here. So looking at it, let's go put it in order here. I'm gonna say CDA is gonna be similar to our other triangle. Let's make sure I keep everything in line here, okay? So C is where the, for CDA, it goes from the alpha angle to the right angle to the 90 minus the alpha. So the other triangle, keep everything in order here, would be similar, would be CBD. Alpha to the right angle down to the 90 minus alpha, okay? So these two triangles are similar. What do we know about similar triangles? Their side lengths are proportionate, and they're similar again by the angle theorem, right? If all the angles of the triangles are the same measurement, then we know the two triangles are similar, meaning their side lengths are proportionate. All right? So we've established that they're similar here. Let's go see if we can find some, well, ratios to help us out here. All right, so let's go see if we can draw a diagram that kind of shows the similar triangles in their order. CDA, let's deal with that one first, CDA. So if I want to make it a right triangle here, CDA, all right, C is the alpha, so we have C here, and then D, right there, CD, and then angle A here. So just for reference, there's a right angle, and I'll put my alpha angle right there, okay? The second triangle, let's put it on the same orientation so we can really see what's going on with CBD. C has to be the alpha, B down here, and D. With that, we know these side lengths are gonna be proportionate. So let's put what we know here. DC has a length of 1, DC, 1 right there. AC has a length of, well, 2, the radius is 1, plus, well, 1 here for AE, so CA is the length of 2, okay? Then from there, we know that in this triangle, DC, or CD, has a length of 1, and CB, we don't know what that is, but we do. Here's the tricky part. If EC has a length of 1, it's the radius, then BC has a length of 1 minus x, whatever the length of EB is. So BC is a 1 minus an x, and now we can make a proportion here, okay? So we know the corresponding side lengths are proportionate, so 1 over 2, so 1 over 2, 1 over 2 is equal to 1 minus x over 1. So from there, let's go solve for x here, cross multiply. You should remember that. We have 1 equals 2 minus 2x. We subtract the 2 to both sides, not too bad. And we have here a negative 1 equals a negative 2x, divided by negative 2. It makes it positive, and x equals a 1/2. And with that, we got our x value being 1/2 right here, and it's a 1/2. All right? Did you get the 1/2 for x? If you did, way to go. If you didn't, but you learned something, hey, that's the whole point of this channel. So please subscribe to our YouTube channel, like this video, share it with your friends. This helps make us, helps make us grow and make more fun math videos for everyone. So, as always here, thanks for watching.